Hi, welcome to our pre-calculus. Today's topic is using a Pythagorean identity to find solutions in an interval for a trigonometric equation problem type 1. What they really meant to say is that we are going to look at tangent, cotangent, secant, and cosecant. We had looked at sine and cosine before, and these other functions are now in play. Here's the first example, secant square of x plus tangent of x equal to 1. So the intention in this section is to go back and study the Pythagorean identities and see which one of them can be used to make all the functions in your equation to be the same. The mismatch of secant here and tangent there, that is a problem that makes the problem issue that makes the problem a bit hard to handle, and the idea is to go back to the Pythagorean identity. Secant squared is same as 1 plus tangent squared, so what we do is take this and replace it by 1 plus tangent square of x. Then there is a tangent of x, so this is replacement for secant, is equal to 1. Now the problem is straightforward to solve. So subtract 1, factor tangent of x times tangent of x plus 1 equal to 0. So this tells us tangent of x is equal to 0, or tangent of x is equal to minus 1. Tangent of x equal to 0 tells us x has to be either 0 or pi. Tangent of x being minus 1, this is x is equal to 3 pi over 4 and 7 pi over 4. Since we didn't have any squaring of our equation or transformations of that type, there's no need to go and check these. We can just simply list them, 3 pi over 4, pi, 7 pi over 4, and then we are all done. As simple as that. So the idea is to use the Pythagorean identities. We had 3 of them. We had used the first one, the most famous one, the sine squared plus cosine squared equal to 1. Several lectures ago, we repeatedly made use of that to cure problems where sine and cosine show up. One of them squared, the other one isn't, and that identity help us. Now, a similar question comes up. For example, here cotangent and cosecant show up in one equation, and one of them squared and the other one isn't. So cotangent square, what do we have for cotangent square? Cotangent, if you wish, you can write this identity in a slightly different form as well. You can write it as cosecant square of x minus 1. Same way here, you can write tangent square of x as secant square of x minus 1. So there is a cotangent square. Cotangent square, we are going to write it as cosecant square of theta minus 1 plus 3 cosecant of theta is equal to minus 3. So this one, we bring everything to one side and write it in order. So 3 cosecant of theta and minus 3 plus comes to left hand side becomes plus 3, and minus 1 is plus 2 equal to 0. If you want to make substitution, be my guest, but probably by now you're comfortable with factoring it as it is. So you could write it a squared plus 3a plus 2, factor it, and then come back and back substitute, or you can just factor it as it is. So say cosecant of theta either is minus 1 or cosecant of theta is minus 2. Well, cosecant is a reciprocal of sine, so this means sine of theta reciprocal of minus 1 is again minus 1, and reciprocal of minus 2 is minus a half. So this one, theta becomes 3 pi over 2, that is And for sine of theta becoming minus 1/2, the angle is going to be pi plus pi 6, 7 pi 6, and 2 pi minus pi 6, which is 11 pi 6. So our answers are 7 pi 6, 3 pi over 2, or if you wish, you can call it 9 pi 6, and 11 pi 6. That is going to handle this problem. How about with tangent square? Again, tangent square can replace by secant squared minus 1. So that is what we do. Secant square of theta minus 1 plus 2 secant theta is equal to minus 1. Minus 1's cancel. All we are left with is this equation. We factor secant of theta, becomes secant of theta plus 2 equal to 0. Two possibility, secant of theta is 0 or secant of theta is equal to minus 2. Remember, secant is 1 over cosine. Now, 1 over cosine never becomes 0. If it was possible for secant of theta to be 0, remember secant is 1 over cosine. Wow, what should I divide 1 by to get 0? There's no such number. Or if you push, it has to be infinity. That's impossible. So this one gives us no solution to follow. The other one is 1 over cosine theta is equal to minus 2, which tells you cosine of theta is minus 1/2. Minus 1/2 cosine of 2 pi third and 4 pi third are the ones that will give us that value. So we notice that sometimes you have a branch of your equation. After factorization, you come to two branches. It's possible that one or both of them are fruitless, that there is no root that you can find there, and then you do accordingly. So what is that we learned here? A bunch of equations involving tangent, cotangent, secant, and cosecant. One was a square, the other one wasn't. And the way to handle these things is through the Pythagorean identities involving these creatures. So you either use it in that style if you have secant squared, cosecant squared. If you have tangent squared or cotangent squared, you use these forms. And the objective is to get an equation just in one function. So of these 6 trig functions, we have to have only one showing up in our final equation. Then we can use the tools from algebra to factor and find our solution. Okay, until next time, good luck and God bless.